Let's explore the C++ Standard Template Library, often called the STL. It is a powerful collection of reusable components that can significantly simplify and accelerate your C++ development. Let's dive in and see what the Standard Template Library has to offer. So, what exactly is the Standard Template Library? Well, the Standard Template Library is a part of the C++ Standard Library. It's essentially a collection of template classes and functions that provide common data structures and algorithms. The Standard Template Library promotes code reuse and efficiency, reducing both development time and the number of bugs in your programs. The key characteristics of the Standard Template Library include generic programming, which makes use of templates. It also provides a consistent interface across various components, and it offers highly optimized implementations. The Standard Template Library also includes type-safe containers and algorithms, and it ensures the separation of data and algorithms. The Standard Template Library consists of three primary components: containers, algorithms, and iterators. Containers are used to store and organize data. There are several types of containers, including sequence containers like vector, list, and deque, associative containers such as set and map, unordered containers like unordered set and unordered map, and container adapters such as stack, queue, and priority queue. Containers automatically manage memory allocation and provide a consistent interface for data access. Algorithms are operations that can be performed on container elements. Common algorithms include searching, such as find and binary search, sorting like sort and partial sort, modifying like transform and replace, and numeric operations, such as accumulate and inner product. Algorithms work with iterators and are not tied directly to containers, which allows for highly optimized implementations. Iterators are pointer-like objects that are used to traverse containers. They act as a bridge between containers and algorithms. Types of iterators include input iterators for read-only access, output iterators for write-only access, forward iterators for read and write access, bidirectional iterators for moving forward and backward, and random access iterators for direct element access. Let's see the Standard Template Library in action with a basic example. This example demonstrates how containers, algorithms, and iterators work together. The code begins with a comment, using vector container, sort algorithm, and iterators. It includes three libraries: IOStream, vector, and algorithm. The main function starts by creating a vector container of integers named numbers, initialized with the values 5, 2, 8, 1, and 9. Next, the sort algorithm from the Standard Template Library is used to sort the elements in the vector. The std sort function takes two iterators as arguments, in this case, numbers.begin and numbers.end, which represent the beginning and end of the vector. A for loop is then used to iterate through the sorted vector, using an iterator it, initialized to numbers.begin. The loop continues until it reaches numbers.end. Inside the loop, each element pointed to by the iterator is printed to the console, followed by a space. The result of running this code is the sorted sequence 1, 2, 5, 8, 9. The Standard Template Library provides a variety of container types, each with its own unique characteristics and use cases. These containers can be broadly categorized into sequence containers, associative containers, and unordered containers. Sequence containers store elements in a linear sequence. Examples include vector, which is a dynamic array with fast random access; list, a doubly linked list for efficient insertion and deletion; deque, a double-ended queue with fast access at both ends; array, a fixed-size array with bounds checking; and forward list, a singly linked list with minimal memory overhead. Associative containers store elements in a sorted order based on keys. Examples include set, a collection of unique keys; map, a collection of key-value pairs; multiset, a set that allows duplicate keys; and multimap, a map that allows duplicate keys. Unordered containers store elements in no particular order, providing fast average case access using hash tables. Examples include unordered set, a hash table of unique keys; unordered map, a hash table of key-value pairs; unordered multiset, a hash table that allows duplicate keys, and unordered multimap, a hash table that allows duplicate key value pairs. Here is an example demonstrating the use of the standard vector. The code starts with include statements for IOStream, vector, and algorithm libraries. In the main function, a vector of integers named numbers is created. Elements are added to the end of the vector using the pushback function. The values 10, 20, and 30 are pushed into the vector. The code then accesses the first element of the vector using numbers at index 0 and prints it to the console. Finally, a range base for loop is used to iterate through the vector, printing each element followed by a space. The key features of vectors are also described. Vectors are dynamic arrays that grow automatically as elements are added. They provide constant time random access to elements using an index. They offer fast insertion and removal at the end, and the memory is contiguous, which improves cache performance. Vectors also provide automatic memory management, and they support range base for loops and standard template library algorithms. Vectors are the most commonly used containers in the standard template library. Here's an example demonstrating the use of the standard map. The code includes IOStream, map, and string libraries. Inside the main function, a map named scores is created. The map stores key value pairs, where the keys are strings and the values are integers. Key value pairs are inserted into the map using the square bracket operator. The keys are the names Alice, Bob, and Charlie, and the corresponding values are their scores: 95, 89, and 92. The code then accesses Bob's score using scores at key Bob and prints it to the console. A range base for loop iterates through the map, printing each key value pair. The first element of each pair represents the key, and the second element represents the value. The key features of the map are also described. Maps store key value pairs sorted by keys. They are implemented as a balanced binary search tree. Keys must be unique and comparable using the less than operator. Maps have logarithmic time complexity for insertions, deletions, and lookups. They automatically sort elements by key and provide direct access to values using keys with the square bracket operator. Maps are ideal for dictionaries and lookup tables. Here's an example demonstrating the use of several standard template library algorithms. The code includes IOStream, vector, and algorithm libraries. In the main function, a vector of integers named nums is initialized with some values. The code then uses the std find algorithm to find the element with the value of 8. The algorithm is called with the beginning and end iterators of the vector, nums.begin and nums.end, and the value to find 8. The result, which is an iterator pointing to the found element, is stored in the it variable. The code then sorts the vector using the std sort algorithm, again passing the beginning and end iterators of the vector. The std count algorithm is used to count the number of occurrences of the value 3 in the vector. The result is stored in the count variable. Finally, the std min-max_element algorithm is used to find the minimum and maximum elements in the vector, and the results are stored in min and max variables, respectively. The slide also lists the various categories of algorithms provided by the standard template library, including non-modifying sequence operations, modifying sequence operations, sorting and related operations, numeric operations, min-max operations, set operations, and heap operations. This slide demonstrates the use of standard template library iterators. The code includes IOStream, vector, and list libraries. In the main function, a vector of integers named vec is initialized with some values, as is a list of integers named list. A vector iterator vit is declared and initialized to the beginning of the vector using vec.begin. The iterator is then advanced by 2 positions using the += operator, so it now points to the third element in the vector. The value pointed to by the iterator is printed to the console, which will output the value 3. Similarly, a list iterator lit is declared and initialized to the beginning of the list using list.begin. The iterator is advanced to the next element using the increment operator, so it now points to the second element in the list. The value pointed to by the iterator is printed to the console, which will output the value 20. The slide then outlines the hierarchy of iterators, including input iterators, output iterators, forward iterators, bidirectional iterators, random access iterators, and contiguous iterators. Why should we use the standard template library? Well, the standard template library offers several benefits. First, it boosts productivity by providing ready-to-use and well-tested components, eliminating the need to rewrite common data structures and algorithms. Second, it enhances performance with highly optimized implementations that often outperform handwritten code, ensuring efficient algorithms across different use cases. Third, it improves reliability with thoroughly tested code, used by millions of developers, reducing bugs and edge cases. Finally, it promotes best practices such as choosing appropriate containers for your data, preferring algorithms over manual loops, and using iterators to decouple algorithms from containers, thereby leveraging the power of templates. For further learning, consult the C++ reference in cppreference.com to explore the C++ standard library in detail. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.